See the difference here. Let us compare the code. See, everything is same, only I added the default. Now the fact that there's a default present, it means that we are saying, when we say, when we are saying this code for the complete case, what it means, I have my select, this is my select line. When select is 0, I am giving I0. When select is 1, I am giving I1. After that, I am coming to default. That means what? These two conditions are covered by default. Here I am giving the input called I2. There is no latch. This is properly a proper combo logic. Let's see what happens in the synthesis and the simulation behavior. So I verilog comp case tb underscore comp case, then dot slash a dot out gtk wave tb comp case dot vcd. So we have I0, I1, I2, select and Y. So let's look at this. See here, we are seeing properly. See, when select is 1 0 or 1 1, it is following I2 completely. See, look at this. This is my I2 in this region. When select is 1 0 or 1 1, in this region it's exactly following I2. Correct? That's what we wrote. Correct? That's what we expected also. When select is towards 2 or 3, it simply follows I2. There is no latching action here. Otherwise, when select is 1, it follows I1. When select is 0, it follows I0. Exactly that is what is happening. That's what is exactly happening. Clear? So there is no latching action. We are seeing that in simulation, and let us synthesize this and see what happens. So read verilog comp case. Comp case, just I named it that way because it's a complete case. So synth-top comp case. So if you see, there should not be any latches inferred here. There should not be any latches inferred. Let's see. So if you see, there are absolutely no latches inferred. It's all combinational gate, and mux, not, or and invert, or gate, all those things. There is no mux. Sorry, there's no latch inferred. So let us do ABC hyphen liberty dot slash mylib. So if you see here, there are no latches. There are no latches. So this is an AND gate, OR gate, clock inverter, and or invert. So absolutely there are no latches here. This is exactly as we expected. So this will effectively simplify into that 4x1 mux Boolean equation. As an exercise, you can work out that and see whether you're getting a 4x1 Boolean mux here or not. That will be a good exercise for you. Okay. So we saw comp case and in comp case. And there's a partial case assigned. Let's look at what is this here. This is another interesting phenomena. This also we discussed in our class. Now we will discuss in our lab also. So there are two outputs here. So let's drop both. This is for my y. So for y, what is going to happen? If it is 0, 0, it's going to be I0. If it is going to be 0, 1, it's going to be I1. And in case of this 2, it's going to be I2. There is no latch here. This is perfectly fine. You have written default statement also. Perfectly fine. Many people, what they think is, if you write default statement, inferred latches are avoided in case. So that is not a complete sticker. That's not completely correct. There are caveats there. That's what we are seeing in this class now. Now let's analyze what happens in case of X. This is my select line, which is a 2-bit line, 1:0. So 1, 2, 3. So for 0, what we are getting? It's going to be I0. For 1, what you are getting? Nothing is mentioned for X here. Kindly note. Here nothing is mentioned. In the default, you are mentioning it to be I1. So for I2 and I3, it's going to be I1. Now here, in this case, it is latch. This is the problem. So what is the condition for latching? When select of 1, select of 0. Let's write it 0, 0, 0, 1, 1, 0, 1, 1. So what is the behavior of X? So select of this is 0, 0 means it's I0. In case of 1, 0 and 1, 1, it's I1. Here it is latch. So in all these three conditions, the latch is transparent, correct? Here the latch is transparent, here, the latch is transparent. So these three conditions together will tell me the latch enable condition, correct? These three conditions together will tell me the enable condition. So what is the enable condition? Whenever my select, if select of 0, sorry, if select of 1 is 1, look at this. If select of 1 is 1, my latch is definitely enabled. Or select of 0 should be low. This is my enable condition for the latch, correct? Correct. When cell of 1 is low and cell of, so this is like, this is, but if you look at this, cell of 1 bar dot cell of 0 bar plus cell of 1 is equal to actually cell of 1 plus cell of 0 bar. There is a theorem by this name, that is A plus A bar B is A plus B. This is exactly following that. It's called redundancy theorem. If you're not aware of it, kindly Google and check this. It's a very important Boolean logic simplification. This is exactly following that. So this is what we expect to be the enable condition. If this condition is not satisfied, there will be a latching action. Otherwise, the latch will be enabled. Let's see what happens in the synthesis and simulation.